Hello, so today we're going to be looking at an example with Y delta transformation and how can we use those to find the total resistance between two branches in a circuit. So here we are given a bunch of resistances and we want to figure out the total resistance between A and B. So we can make use of the Y delta transformation we saw the other time. We can just start by labeling these resistors for easy application of the formulas we derived last time. So we can call this RC, we can call this RA, and we can call this Y naught RB. And so we see from here, this triangle, we can form a star that would look like this. Oh, sorry, we have resistance here, we have another resistance or resistor here. So this star will be equivalent to this. Let's just call this maybe R1, and let's call this R2, and let's call this R3. So in this manner we can come up with an equivalent circuit that looks like this, where we have here we're gonna have R2, which will just be equal to RA multiplied by RC over the sum of all the resistances previously in the triangle, and this is just 18 over 12, which gives me 3 over 2 ohms right there. And this resistance here, which we called R1, will just be equal to RC multiply RB over the sum of all the resistances we had there. And this is just equal to, same thing, 18 over 12, which is still 3 over 2. And then ohms right there. And then we had this resistance here, which we called R3, which is nothing but RB multiply RA over the sum of all the resistances. So this is equal to 9 over 12, which is just 3 over 4 ohms. Okay, so now we have these resistances, which are in series. So these resistances are in series, and the whole branch, this branch here, is in parallel to this whole branch here. So we have a parallel connection between these two. So we can just transform this to the next circuit here, which is just 4 plus, because we had this in series with R1, so that will be 4 plus 3 over 2, which is in parallel with 2, I think this was 2 ohms plus 3 over 2, so 2 plus 3 over 2, and this gives me 4 over 2, 4 plus 3 over 2, this is 11 over 2, and this will give me 7 over 2. And so if I get 11 over 2 in parallel with 7 over 2, that gives me 11 over 2 multiplied by 7 over 2 divided by 11 over 2 plus 7 over 2, that gives me 11 plus 7 over 2. And so if I add everything, I get 77 over 2 times 18, that's 77 over 36 ohms. And this other resistance is just the R3, which stays at source, so this is 3 over 4 ohms. So that means the total resistance, that's the resistance between A and B, will just be the sum of these two resistors, so 77 over 36 plus 3 over 4, and that just gives me simplifies to 26 over 9. That is roughly 2.89 ohms. Okay, so let's just go ahead and try to simulate this circuit on Multisim and see if we get any values close to the calculated value. So we're gonna need 5 resistors, a 4 and then 5. Okay, so let's just rotate all these 4 resistors so they look like this, and let's take this one here, let's just take this one here. Okay, let's take this one here. Okay, make it here, and let's take this one, I guess here. Okay, okay, this one, take it right in the middle. Okay, so we're making branches A and B. So this is branch A and this is branch B. Okay, make it this way, so this will make a connection here, this make a connection here. I think this is connected to this, this is connected to this, and we have this head connected to branch A, this one as well, this one connected to branch B, I guess, yeah, connected to branch B. Okay, this is connected here, and this is connected here. So we're gonna need a multimeter. So let's set our multimeter, let's just rotate this so it faces this way, and we connect it between here and here. Okay, let's just set the values of our resistances. I think this was 4 ohms, this was 2, and we needed this one 3. Okay, this was 6, I guess, yeah, 6, and this was 3 ohms. Okay, so maybe we just set our multimeter to ohms, and then yeah, we're good to go. And let's see what value we get. Oh, we get approximately 2.88, which is not very far from what we calculated.